Okay, question 6. This one's a loggy one, and remember that my solutions are just unofficial solutions. They're not official in any way, shape or form. If we rearrange that one there, it'll make it a lot easier for us. Just rearrange it like that. Now we do some surgery on the left hand side using the log laws like that, and it's shaping up very nicely. We can do a little bit more with that, and we can say log of x to the half base e equals 3. Now, if we just reorganise that a little bit so that it reads like that, in other words, base to index equals this, okay? Now, what are we going to do now, guys? We are going to square both sides to get x. Yes, x equals e to the 6. Isn't that beautiful? And that's the answer. Right, what do we got now? Question 7. We've got a derivative, and it looks like we have to anti-differentiate to get the answer to this, and we've got a boundary condition over here which we can apply to work out what c is. That's our game plan. Let's go for it. Therefore, f of x would be, now the antiderivative of this beastie here is this, and the antiderivative of minus sine 2x is plus a half cos of 2x, and then we've got the plus c. So let's apply our boundary conditions now. We've got subbing x equals pi on 2 and y equals a half. Let's do that. We've got a half equals this. That term there is equal to 1, isn't it? This term here, cos of pi, is minus 1. So that let's do that now. And what do we get? A half equals 2 minus a half plus c, because that's minus 1, and a half of minus 1 is minus a half, isn't it? Yes, very good. Let's just work out what c is now. So therefore we've got a half equals 1 1/2 plus c, therefore c is going to be minus 1. Fantastic. So there's our f of x, and we're done. And we're out of here, on to the next question. Now, this is a continuous random variable question, probability density function given by that thing. For x is 0 and above, and 0 everywhere else. Pretty standard looking thing. The median of x is m. Determine the value of m. Well, we know how to do that. That's the equation we need. Okay? Alright, we're good to go. We can anti-diff this thing here, and then as a definite integral, we get that. Now, remember guys, that the anti-diff of e to the minus a fifth of x, you divide by the minus a fifth, which is the same as multiplying by minus 5. So multiplying this term here by minus 5, you just get minus 1. So minus e to the minus x over 5, evaluated between 0 and m, comes to a half. So fleshing that out a little bit, what I've done there is I've got rid of the minus here. I've multiplied both sides by minus 1. Call that equal to minus a half. So it's plus e to the minus x over 5 from 0 to m, evaluated, gets us minus a half, okay? Now, we'll substitute these terminal values in, and we'll go in for the kill. So basically we've got e to the minus m over 5 minus e to the 0, okay? Now that's going to be 1. So e to the minus m over 5 minus 1 is minus a half. Now just rearrange. We've got e to the minus m over 5 equals plus a half. Now we better take the log of both sides base e to get that m where we want it. So therefore minus m over 5 is going to be log of a half. I can rearrange that as minus log of 2. Yes, so therefore that will get us plus m over 5 is plus log of 2 base e, if you know what I'm trying to do, and therefore m will be 5 log 2 base e. Yes, that's question 8a. Alright, that's what m is. Now what have we got to do now? The value of m is a number greater than 1. Well, thanks for telling us that. We'll work out the significance of that in a minute, I think. Find the probability of x being less than 1 given that x is less than or equal to m. Well, that's we can set the equation up. The probability that we require is the probability that x is less than 1 and x is less than or equal to m over the probability that x is less than or equal to m. And of course this is going to be a half, guys, because it's the median, right? It's the median. Now, well, I think that's where our little bit of information comes in handy, this bit up here. The value of m is a number greater than 1. So if you think about that, for example, if m was, for example, say 2 or 3 or something, just pick a number more than 1, then this would be the probability that x is less than 1 and x is less than, say, 2 or 3. This one here is the stricter condition, isn't it? So therefore, this would be the probability that x is less than 1 would take care of both of those, yeah? So that's why they're giving us that bit of information, because this is a tech-free exam and we just can't dive for the calculator. So therefore we've got it worked out, guys. So therefore what we need is as this says, if m is greater than 1, then this probability here is the same as the probability that x is less than 1, as I was just saying. Hence we've got that there, okay? Now, we need to work out what the probability is for x being less than 1. So we've got to go through this all again. That shouldn't be too hard. We've done it once before now. So let's go for it and evaluate it. It's going to be minus e to the minus x over 5 evaluated between 0 and 1. Alright, that's what you get. So it's basically 1 minus e to the minus a fifth. Hence we need the probability that we require is, that's the numerator, that's the denominator, as I was saying before, because it's the median for the denominator, so the probability is a half, and that gets us the answer there. Alright, there is our answer. Yes? Terrific. Now, let's keep going. New question, question 9. Sally aims to walk her dog, Mac, most mornings. If the weather is pleasant, the probability that she will walk Mac is 3/4. If the weather is unpleasant, the probability she will walk Mac is 1/3. Assuming that pleasant weather on any morning is independent of pleasant weather on any other morning, yes, we get that. Alright, this is conditional probability. A, in a particular week the weather was pleasant on Monday morning and it wasn't pleasant on Tuesday morning. Find the probability that Sally walked Mac on at least one of these 2 mornings. Alright, I think we can get all that. I like to do a transition matrix, guys, so just please allow me to do that. It summarises everything beautifully. So let's put in the numbers that they've given us about Sally walking the dog. It's a 3/4 probability that she will walk given that it's a pleasant day, right? That's what they're saying. And therefore this other one here has to be 1/4. And the other bit of information they give us is that there's a probability of a 1/3 if the weather's unpleasant that she will still walk. So that's that one there, isn't it? Walking given not pleasant is a 1/3, and therefore this beastie down here has got to be 2/3. Alright, now what have we got to do? We've got to find the probability that Sally walked Mac on at least one of these 2 mornings. Alright, well I like to play contrarian because I think that's the bit an easier way to go. The probability that she walked at least one day is 1 minus the probability that she didn't walk at all, because that's really easy to work out, okay? It's just an easier way to go. So therefore the probability we require is 1 minus, now, the probability that she didn't walk on the Monday given that it was pleasant, times the probability that she didn't walk on the Tuesday given that it wasn't pleasant, and we can just look these up from our transition matrices, no problem. So didn't walk given it was pleasant is 1/4, and didn't walk given that it wasn't pleasant is 2/3. There it is, guys. So it's 1 minus 1/4 times 2/3, which is 1 minus 1/6, which is 5/6, and that's the answer. Yes? Jolly good. Now, what have we got here? In the month of April, the probability of pleasant weather in the morning was 5/8. Alright, now they're telling us what the probability is that it's going to be pleasant weather. Find the probability that on a particular morning in April, Sally walked Mac. Alright, I think we need a tree diagram here. Tree diagram to the rescue. There's the first thing, that it's pleasant or not pleasant, part of the tree. The other part of this compound event is whether she walks or doesn't walk the dog. So, I'm just getting these straight from the transition matrices here, okay? This is straight from it, okay? Now what we've got to do is work out the probability that she's going to walk the dog, alright? So there's a walk and there's a walk. So we've got those 2 events there to work out the probabilities of and then to add those up. Right, there's the first probability. That's walking on a pleasant day. That comes to that. And there's the probability that she walks on an unpleasant day. That comes to that. We've just got to add those up. Okay, so we get 15 over 32 for the first one, and add an eighth. We better turn that eighth into a denominator of 32. So we get that, and it looks like we've got 19 out of 32. Terrific, that's the answer. Alright, the next part. Using your answer from part B, 1 or otherwise, find the probability that on a particular morning in April the weather was pleasant, given that Sally walked Mac that morning. Let's put our formula out here and try and work out what we're doing. The probability that it was pleasant given that she walked is the probability that it was pleasant and she walked over the probability that she walked. And guys, we worked out the probability that she walked in the previous question, which was 19 out of 32, wasn't it? Alright, and from our tree diagram we can work out the numerator anyway. That's right, the probability that she walked was 19 out of 32 from part B1, and also the probability that she was pleasant and she walked was the very, very top twig of our tree diagram on the previous screen. And that was 15 out of 32, so we can just plug and play into our formula, and we get that. The 32s will cancel out, and the answer is going to be 15 out of 19, guys. Fantastic. Okay, question 10, last question. A line intersects the coordinate axes at the points U and V with coordinates these for U and these for V respectively. Here's U, here's V. Okay, we get that. Where U and V are positive real numbers, and U apparently goes from 2.5 up to 6 inclusive. Now, we might have to just come back to this as to what the significance of this is later as we get into the question, I think. But for part A, when U equals 6, the line is a tangent to the graph of y equals ax squared plus bx, which is this quadratic here, at the point Q, there, with coordinates 2 and 4 as shown. Alright, I think we get this. If A and B are non-zero real numbers, find the values of A and B. Alright, I think we can do that. I think we can rustle up a couple of equations in A and B and then solve them simultaneously. I think is probably our game plan. One of them will be based on gradient, I think, and one of them will be based on subbing in these values into the original function, I would imagine. So let's go with that. Dy dx is 2ax plus b, as we can see. Now, the gradient of QU, okay, do you see that? QU, okay, is y2 minus y1 over x2 minus x1, which is 4 minus 0 over 2 minus 6, because u is 6 in this case, guys. That's 4 over minus 4, which is equal to minus 1, yes? So when x is 2, which is the x-coordinate at Q, we know that 2a times 2 plus b equals minus 1, don't we? Yes, because we found the minus 1 up here. Yes? Now there we've got our first equation. 4a plus b equals minus 1. Now let's sub x is 2 and y is 4, the coordinates of Q, into just the rule, the y equals ax squared plus bx rule, and we'll get another equation. There it is, and now we've just got to solve them simultaneously for a and b, which is going to be very easy. If I subtract 2 from 1, I'm going to get minus b, aren't I? Equals minus 5, which means b is 5. That's great, isn't it? Now we just sub that back into equation 1. Will do, and therefore we're getting 4a plus 5 equals minus 1, therefore 4a equals minus 6, and therefore a is minus 3 over 2, and b was 5, so that's it. We've done part A of this question. A is minus 3 over 2, and b is 5. Alright? Great stuff. Now, part B, the rectangle OPQR, good heavens, what's this? OPQR has a vertex at Q on the line, okay? The coordinates of Q are 2, 4 as shown, and what we've got to do is find an expression for V in terms of U. Alright, they're hotting it up now, guys. It's getting a bit ugly. However, we will press on regardless, and we will be victorious. Now, just feasting your eyes on that for a while, there's got to be a connection. There's got to be a connection between V and U. And after reflecting on it for a few seconds, I think it's clear that the gradient is going to be the connection, because the gradient of here to here is the same as the gradient of here to here, and we can work out this gradient very easily, and it's just going to have the only pronumeral it's going to have in it is going to be a V. We can work out this gradient, and the only pronumeral that's going to have it in it is going to be a U. And if the gradients are the same, we can set both expressions equal to each other, which will give us a connection between V and U. If that was all just too confusing, let me show you. Consider the line segments VQ, that is the upper one here, and QU, which is the lower one, alright? Now, they have the same gradient, guys, so therefore MVQ equals MQU. So, as I was saying, you just plug and play. So, V, that's Y2 minus Y1 for VQ, that's V minus 4 over 0 minus 2, equals the same thing for line segment Q to U. That's 4 is Y2 minus 0 is Y1 over 2 minus U, okay? There is our connection. So we can therefore just pretty that up a bit, and we'll get that. And what are we trying to get in terms of what? Trying to get V in terms of U. Well, we've almost got it. Just add 4 to both sides. There it is. There's our connection. Now, I just saw fit to pretty that up a little bit, but that would have been perfectly acceptable to leave it like that. And in doing this, I run the risk of making an error. So more fool me, but I just thought I would do that, and I was confident to do it, because it might help me later on, because obviously this is all leading somewhere, this connection between V and U. So cancel that out and just write it out like that, and then that. So that is V in terms of U, alright? Okay, so far so good, guys. Find the minimum total shaded area and the value of U for which the area is a minimum. There's our diagram again. Now, we're talking about the shaded area. Alright, well, I think we've got to get an expression or an equation for the shaded area, which I think the easiest way to do that, guys, would be the triangular area from V to O to U, that is from there to there to there, minus this rectangular area, which is going to be just 4 times 2. So, would you agree? So, the shaded area is the area of triangle VOU minus the area of rectangle OPQR, yes? Now, that's going to be, the triangular area is just the base times the height over 2, which is U times V over 2, minus 8, which is the rectangular area. Okay, that's nice and simple, isn't it? Now, they're asking us for the value of U for which the area is a minimum. So, we better get that area expressed exclusively in terms of U being the variable, okay, and we've got the relationship on the previous screen between U and V. So there it is, I've just plugged in V in terms of U, and now we've got the whole thing in terms of U, okay. So what do we get? We get that, okay, 2U squared over U minus 2 minus 8. Now we can do dA du, and we're off to a flying start. So it's a bit ugly, it's quotient rule, so you just got to keep your head. It's 2 times, now as I say, it's bottom d top minus top d bottom over bottom squared. So it's, what am I saying? It's denominator times derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared, and the whole thing's multiplied by 2, alright? This doesn't give us a derivative term at all, because that's a constant. So now we've just got to clean this up, and we should be pretty right, I think. So, 2u squared minus 4u minus u squared over that denominator squared. Something is going to happen here, these terms here. We can clean that up. We get that. Alright, now that's dA du. So if we set that equal to 0, that's just factorising it a bit more. And if we set it to 0, then this is what we get. That. Now, when you multiply both sides by the denominator, mercifully, the left-hand side still equals 0. And you get 2u into u minus 4 equals 0. Therefore, u equals 0 or u equals 4. But of course, guys, we know that u had to be that bit of information back there we were wondering about. U has to be between 2.5 and 6, so it can't be 0. So, therefore, u equals 4. Yes, yes, and yes-a-rooney. We've got it. U equals 4. Now we've just got to work out what that area is for that value of u equals 4. So A min equals, here's our equation up here for the area. So it's this thing here, repeated from up there, and I'm going to sub in now, u is 4, and it's going to get us that, which is going to get us that, cancelling, and therefore it's going to be 8. I can see it. There it is, A min is 8. So therefore u is 4, and A min is 8. Yes, 8 is great. Now, is there anything else they can do to us, guys? Oh, yes, there is. Find the maximum, well, we just found the minimum, the maximum total shaded area, and the value of u for which the area is a maximum. Look, do you know what? I smell an absolute maximum here. So I think what we'll do is we'll plug in the value of u for 5/2 and the value of u for 6 into the area formula, and I'll bet you what you like, we get figures which are more than 8, which was the minimum area. So yes, the max must be an absolute max from one of the endpoints. So let's plug in u is 5/2, and therefore there's our area formula. I'm plugging and chugging here, guys, and just going with it. It's not pretty, but it's easy to fix by a bit of cancelling. So 25 minus 8 is 17, isn't it? Yes. Now we plug in the other one here when u is at the other end of the spectrum here, when u is 6, and we see which one's bigger, and that's our answer, guys. Yes, yes, 2 into 4 goes twice, that's 2 into 36, 18 minus 8 is 10. 10! So this one was 10, this one was 17, this is the winner. This is the winner when u is 5/2, A max is 17. And that's the end of the road. We've just finished the paper. So there you go, guys. That last question was a bit ugly, but if you kept your head and if you had enough time, it was quite doable, providing you didn't stress out and just allowed yourself to see the wood for the trees. All right, I'm getting out of here now. I hope you got something out of that, and we'll see you again soon.